out, but then something also stays inside. Okay, so the properties you have used to simplify radical expressions involving square roots also hold true, or I'm pretty sure that's hold true, for expressions involving nth roots. Okay, so for any real numbers a and b, and any integer n greater than 1, okay, so integer n here has to be greater than 1, the nth root of ab is equal to the nth root of a times the nth root of b, if n is even and a and b are both non-negative, or if n is odd. Okay, so this is what we kind of did yesterday. We have two roots multiplied together. We can get that single root there. Same thing with our cubed roots. So in order for a radical to be in its simplest form, the radicand must contain no factors that are nth powers of an integer or polynomial. Okay, so we are going to continue simplifying today. Okay, we're just going to have some remainders. Okay, I'm just going to call them remainders. So for letter A, just like I did yesterday, I'm going to split this so that I have the square root of 12 and the square root of c to the 6th, d to the 3rd. Okay, so I want to simplify the square root of 12. So I want two numbers that multiply into 12 where I can take the square root of one of them. Okay, that would be 4. So I can split the square root of 12 into the square root of 4 times the square root of 3. Okay, do you see how I did that? Because I can take the square root of 4. Okay, the square root of 4 is just 2. And then I still have the square root of 3. Now I have to simplify my variables. Okay, so I want to take the square root of c to the 6th. Okay, c to the 6th. What is that? We did this one yesterday. C to the 3rd. Okay, so bring that down. C to the 3rd. And then I also have the square root of d to the 3rd. Okay, so if I take 3 and divide it by 2, I get 1, right? But I have a remainder, correct? You have a remainder of 1. So once I divide here, I get 1, and then I have a remainder of 1 that needs to stay in that radical. Okay, so that comes to right here. Now I'm going to make this look a little bit nicer. So I'm going to combine all the numbers that are on the outside. So we have 2c cubed d. And then in my radicals here, I have 3d left. Okay, and that would be my simplified answer. So yesterday we had those perfect squares where it just simplified and we could get rid of our radical. In this one, you'll have a couple perfect squares, but you will still have some numbers left in that radical symbol. Questions on letter A? Okay, then moving on to letter B here. This time we have a cubed root. Okay, cubed root. I'm going to do the same thing I did before. So I have the cube root of 27. And then I also have the cube root of y to the 12th and z to the 7th. Is there a cube root of 27? How do I figure out if there is? Is it what? It is 3. Okay, the cube root of 27 is 3. If you didn't know that, you can always check on your calculator. Okay, you can always check on your calculator. So the cube root of 27 is 3. That one is a perfect one there. Now I'm just going to do the same thing we did yesterday. So I can take my power and divide by my root. Okay, so I have 12 divided by 3. 4. Okay, now I have 7 divided by 3. How many times does 3 go into 7? Twice. So that means I would have z squared. But then how many are remaining after I divide 7 by 3? If I have z squared, I have 1 left over. So 1 goes in that radical. And it is a cube root, so don't forget to put that 3 there. Gets a little squished, but. Okay, and that would be your simplified answer. Okay, so you have to look for those remainders to remain inside your radical symbol. Okay, questions? All right, why don't you guys try C and D? If you don't know what the cube root of 125 is, find a calculator. We did that yesterday. Okay, plug it into your calculator, find that cube root, find that fourth root. If you want to borrow a calculator, I do have some. Thank you. Yep. Oh my gosh, we have mixed advisory today. Yeah.
Yeah, apparently we're finally getting back on our normal schedule.
Yeah, so with the we'll replace that. So that'll be a cube. And you will do the same thing with like 4 and 5. Yeah. You asked me if I was right.
I know, it's wrong.
I was gonna tell you. All right, so let's go over these two problems here. So we have the cube root of 125 and the cube root of m to the 30th and p to the 20th. Okay, so the cube root of 125 is 5. Okay, cube root of m to the 30th. Again, I can just take my power, divide it by my root. So I have m to the 10th. Okay, so here I have p to the 20th, and I need to divide that by 3.
May I have your attention, please? We are under a soft lockdown for K-9 SIP. Please ignore all bells and remain in your classroom. Thank you.
All right, so 20 divided by 3. How many times does 3 go into 20? 6 times. Okay, then how many do I have remaining? 2. So I would have p squared. And don't forget that cube root. Okay, so don't forget to write that little 3 back in your radical. Okay? How'd we do on that one?
I got it right, so alright.
Proud of you.
That's pretty good.
All right, so letter D then. We have the 4th root of 16 and the 4th root of a to the 24th and b to the 13th. Okay, the 4th root of 16 is 2. Okay, so I have a to the 24th and I need the 4th root of that. That will be a to the 6th. Okay, then b to the 13th, 4th root of that. That will be b to the 3rd. And then I'll have the 4th root of b remaining. So I'll have 1 remaining there. Okay, questions on those ones? Very similar to what we did yesterday, except you do have those remainders. Okay, that's all that's different. All right, then. Quiet now. Hey, focus. Next, we're going to move into the quotient property of radicals. So this is when you have a fraction. Okay, so for any real numbers, a and b, where b does not equal 0 and any integer n is greater than 1, we have the nth root of a over b is the same as the nth root of a divided by the nth root of b. So we can split it just like we could our multiplication ones there. So if I have the square root of 27 over the square root of 3, I can combine those roots so that I have the square root of 27 over 3, and 27 divided by 3 is just 9. So that's where they're getting the square root of 9 from, and that just equals 3. Okay, so we can split our quotients here. All right, so looking at the back then, to eliminate radicals from a denominator or fractions from a radicand, you can use a process called rationalizing the denominator. To rationalize the denominator, multiply the numerator and the denominator. So numerator and denominator by a quantity so that the radicand has an exact root. Okay, so you're multiplying by a version of 1. Okay, you have to multiply by a version of 1, meaning you're multiplying the same number to the numerator and the same number to the denominator. Okay, that's just 1, so you're not changing the number itself. So if we have 2 over the square root of 3, we don't want that root in the denominator. Okay, so we would multiply by our version of 1 here, which is square root of 3 over square root of 3. Okay, that version of 1 has to do with your root in the denominator. Okay, so that's what you multiply to the numerator and denominator, is your denominator itself. From there, you would just multiply straight across to get your simplified answer. Now that's with a square root. If you have an nth root, in this case, this example is a cubed root. Okay, I have the cube root of 2. So I would want to multiply not just by the cube root of 2, but the cube root of 2 squared. Okay, that squared needs to be there so that when you multiply across, you end up with the cube root of 2 cubed. Okay, so that cube and that cubed root can cancel out. Okay, because you need that radical to cancel. So you can't just multiply by that same number. You do have to change it a little bit when you have that nth root. So this is the rule for that right here. You take your b to the x power, and you take your root, which is n, and subtract from it. So our root was 3. Our 2 was raised to the first power. So I had 3 minus 1 to get this 2 right here. Okay, so that's all that's saying. And I'll do an example of that in a little bit. So we do want to do a couple examples of these because these ones seem to be a little bit confusing. So make sure you are paying attention as I'm going through each of these examples. So letter A, we have the square root of a to the 9th over b to the 5th. I'm going to change that. So I have a square root of a to the 9th over the square root of b to the 5th. Now I want to do what we did on the front. I'm going to simplify first. Okay, I can simplify both of these, right? So I have 9 divided by 2. Okay, I have 4, and then I have a remainder of 1. So that would be the square root of a. Shh, guys, this is the harder part. You got to pay attention. Okay, simplifying the square root of b to the 5th. So 5 divided by 2. That would be 2. And then I do, again, have 1 remainder. Now I don't want this radical in the denominator. So since it's just a square root, we can do what this first example shows. We just take that denominator with the root, multiply it to the top and bottom. So only the square root part. So that would be the square root of b. So this is my version of 1. And that's square root of b over square root of b. Shh. Stop talking. From here, I just want to multiply straight across. So I have a to the 4th. If I have the square root of a times the square root of b, I just end up with the square root of ab. Okay, that's over. We have b squared. The square root of b times the square root of b is just b. Okay, that's what I want to do when I'm canceling out that root in the denominator. I don't want it there anymore. It should cancel out. So I'm going to make this look a little bit nicer in the denominator. So we have a to the 4th times the square root of ab over b cubed. And that would be your answer. Questions? All right, letter B is different. Okay, this is the more challenging type. Okay, so I'm still going to split this into 2 different roots. So instead of just having 1, I'll have the cube root of 2 over the cube root of 9x. So I can't simplify this one like I could the first one. So I need to multiply using this rule here. So my n value is 3. Okay, 3. My x to the 9th, right, or x to the 9th. My 9x is raised to the first power. So that's your x here. So I would have 3 minus 1. That's what I need to raise my version of 1 to. So I'm going to multiply by the cube root of 9x squared.
The soft lockdown is complete. Please go back to your normal routine. However, at this time, no one is allowed to leave the building until an all clear is given. Again, the soft lockdown is complete. Please go back to your normal routine. However, at this time, no one is allowed to leave the building until an all clear is given.
Okay, do you see where I got this cube root of 9x squared from? Yes? Alright, so I'm going to multiply straight across. So I have the cube root of 2 times 9x quantity squared over, I'm just going to show you what this does. So if I have this cube root, if I multiply these two together, I would end up with 9x cubed. Okay, that's what I want to happen, because then this cube and this cube root will cancel each other out. Okay, that's why this 9x is squared. Okay, from here we're just going to simplify a little bit. So we have cube root of 2 times 9 squared is 81. And then we have x squared over, again I said these two should cancel. So I'm left with 9x in the denominator. Okay, I can simplify these numbers here because there is a cube root within them. So I can separate 81 into 3 times 3 times 3 times 3. So that's what I'm going to do here. Okay, so I have 3 times 3 times 3 times 3. And I'll show you why I did that in a second.
That's the final form.
No. So when you have a cube root, you're always looking for quantities of 3. Okay, I do have 3 3s right here. So I could take out one of them, right? Okay, so I have a 27 here. Okay, I can take the cube root of 27. So I'm going to take a 3 out. Okay, then what's remaining in my cube root on top here is 2 times that remaining 3, which is 6, and x squared over 9x. Can I simplify that further? Yes, I can. I have a fraction right here. I have 3 divided by 9. Okay, both of those divide by 3. So I end up with 1 and a 3 here. So my final answer would be the cube root of 6x squared over 3x. All right, questions after looking back at letter B? Because I'm multiplying 9x to the first times 9x squared. So I have a 1 and a 2 to get a cubed. That's what you want to do in this case when you have that cube root. So we'll do the same thing in letter C too. All right, we're going to do letter C then. Okay, same thing, split it first. Okay, split it first. So we have the 5th root of 3 over the 5th root of 4y. Okay, I have to multiply this by a version of 1 using a 5th root. And somehow I need to cancel out this 4y with that 5th root. So what power should I raise 4y to? If this is 4y to the first, to the fourth. Okay, I should raise it to the fourth power. Okay, you always want this to add up to your root. Okay, you want your powers here to add up to your root so that they can cancel out. Okay, multiply across here. So I have the fifth root of 3 times 4y to the fourth over the fifth root of 4y to the fifth. And again, this root and that power should be the same so that they can cancel out. All right, here I have 4 to the fourth power. So I'm going to write that as 4 times 4 times 4 times 4. Okay, then my root and my exponent should have canceled to get 4y in the denominator. Now, these 4's, what multiplies to get 4? 2 and 2, right? So this first 4 would be 2 times 2. This second 4 would be 2 times 2. This third 4, 2 times 2. Last 4, 2 times 2. I'm doing this so that I can group 5 of them together. I know it's hard to see. I want to group 5 of them together. So I have 1, 2, 3, 4, 5. These 5. I can take one out. I wanted to do that so I know how many I had left. Okay, there were 3 left here. So I'm going to take one of those 2's out of that root. Okay, so I have 2 times the fifth root. What I have left in here is 3 times 2 times 2 times 2. What is that? Well, I have 6 is with 3 times 2 times 4 is 24. And then y to the fourth over 4y. Can I reduce that fraction? Yes, to 1/2. So my final answer here would be the fifth root of 24y to the fourth over 2y. Okay, so again, those fraction ones are slightly confusing, so you do need to make sure you're practicing those ones. Okay, if anything on your assignment, please practice those ones. Don't skip them because they're hard. Okay, you need to practice them so you know how to do